Okay, guys, moving on from our last part that we talked about, we talked about our trigonometrical ratios, the application of the trigonometrical ratios in calculation of sides, calculation of angles. So this is a continuation, and this is just a 2D trigonometry that we're just talking about, which goes further to the part of the angle of elevation and the angle of depression. Make sure that you watch also those videos after these introductions so that at least you'll be able to understand how to apply this typical approach. So these are just typical questions that you'll be given, and we just need to see how do we apply our trigonometrical ratios in calculation of these. All right, so like I said, always whenever you're dealing with your 2D trigonometry, working with the right angle triangle, you need to go back to the normal part of our ratios, the sine of theta, the cosine of theta, and so forth, which we said we can take these ones from our mnemonics, which is SOHCAHTOA. All right, so that is SOHCAHTOA like that, meaning to say for the ratio of a sine, which is equal to the opposite over the hypotenuse, we talked about this, and also the ratio of a cos, which is adjacent over the hypotenuse. So that's the cos of the angle is equal to the adjacent over the hypotenuse, and the tan of the angle, which is the tan of theta, is equal to the opposite over the adjacent. And I say these ratios, they can be used in determination of sides and also angles, to calculate sides and angles. So whenever you see these trigonometrical ratios, think of calculating sides and angles. Okay, so you must think of calculating what? Sides and angles. All right. So I just hope you're together there. We are supposed to be thinking of these two to calculate the sides and to calculate the angles. So that is the problem solving that you are going to be talking about on your 2D. Okay, that is the questions of this nature where we are given on F in the diagram, we are given that BD, the side of BD, this one is perpendicular. So this sign represents perpendicular to, all right? So they are saying BD is perpendicular to, perpendicular to AC. That is what they are saying here. So meaning to say they are at 90 degrees. BD and AC, they are found at what? 90 degrees. So we've got a right angle triangle, and consider that this is a straight line. And we know that angles on a straight line, they add up to 180. So meaning to say, if we subtract 180 minus this 90 here, we are going to remain with another 90. So this angle also is 90 degrees, because they are on a straight line, okay? So the question was to calculate the length of AC, which is the length of AC, this one, okay? The wall of this AC. Okay, that is actually, this is 35 meters, okay? I'm just gonna think it's 33.5, but it's 35, okay? Let's take it as 35 meters, okay? I'm seeing that one like 35. So this is what you're going to do, guys. Like I said, the application of your trigonometrical ratios can be used to calculate sides. So what you want to do is to calculate the side AC from A to C like this, okay? And considering the part that I'm saying, this is a right angle triangle, this is also a right angle triangle. So we've got two right angle triangles, this one and this one. And on these two right angle triangles that we have, which is CBD and ABD, we can use the first triangle, this one, to calculate the side CB, okay? We use the second triangle from our ratios to calculate side BA. Okay, so I want you to see something here. Let me just try and see if I'm going to win. I think I'm just gonna win. Let me just choose something that can work. Is this gonna work? All right. So let's just do this. So this is the triangle that you're gonna focus with, all right? So we're gonna just focus with this triangle here. All right, so like I said, let's hope I am going to win. Okay, seems like, what happened? What just happened? Okay, Sorry for that, guys. Okay, let me use this one. Let me use this one. So this is the triangle that I want you to focus on, this one, okay? This triangle alone, all right? I'm just hope it's not going to affect me if I remove this side. Okay, it's a little bit bigger. Okay, it's even going to remove, not a problem. But I just hope you see what I'm trying to say. This triangle that you see here, this one, okay, alone. I want you to concentrate on this alone, this one alone. All right, so I want you to concentrate on this right angle triangle. Okay, this is our first right angle triangle. So what you're going to do is that you have an angle inside this triangle of 42 degrees. This is a right angle triangle. So according to that angle, you're going to name what you're given. Remember, we are focusing with this triangle here. So we are going to name our sides, okay? Remember, we want to calculate AC, okay? Remember that we are supposed to calculate AC. We do not know this. And I said AC, we can combine CB and AB, or BC and what? And AB. So we can just find this AC as AB plus BC, okay? Okay, gonna just find AB plus BC. So on this triangle, there is BC, this one. So you're gonna calculate this side of what? Of BC first, all right? So let us calculate BC, okay? So calculating BC, if we check properly, according to this angle, you'll see that this is the opposite side, okay? This side here, it is opposite to the angle that we are talking about, which is BC. I mean, the angle 42 degrees. And this BC is adjacent because we've got the angle of 42 degrees and 90 degrees. They are sitting together on this line. They are together, they're found together on that line. So meaning to say this side is the adjacent side, okay? So you focus on what you are given, okay? This is where you put your focus, what you are given, what you want to find. What is it that you want to find? What is it that you want to determine, which is the value of the unknown? These are the two things that you must mention. So in this case, I'm given 35 meters, which is opposite. What do I want to find? I want to find this side, which is the adjacent. So I have to look for one ratio here that has got opposite and adjacent at the same time. There's only one ratio that has got opposite and adjacent at the same time, which is the ratio of tan, opposite and adjacent, which is the ratio for tan. So writing this formula, we are supposed to have as the tan of theta, whereby theta is the angle of what? Of 42 degrees. So the tan of 42 degrees is equal to the opposite. According to this triangle, our opposite is 35 meters, which is the side of 35 over the adjacent, which is the side BC that we want to calculate here. So we have formed an equation. Once we've got this is an equation where we can solve for BC. This is same as over 1. So we can cross multiply or just multiply by BC. That side is same as what? Cross multiplying. So BC multiplies the tan of 42, which is BC. Tan of 42 degrees is equal to 1 times 35, which is 35. So how do you find the side BC? You divide here by this tan 42, okay? So I'm just going to put my calculator. And also, we are just going to have our answers, let's say, to 2 decimal places, okay? Let us just put our answers to 2 decimal places. So this is what you're going to do on your calculator. Just going to need your calculator so that you'll be able to simplify here. So on your calculator, like I said, you're going to divide 35 divided by tan 42. So you're going to divide by this tan 42 degrees here, close your bracket. That will be 38,87. So we can even round off to 2 decimal places on our calculator by doing this shift. You go to the setup, then you go to fix on 6, okay? Then to 2 decimal places, you press 2 like this. So it gives your answer to 2 decimal places, which is 38,87, okay? So this is 38,87 in meters, okay? You use the units that you're given already here. We are given in what? In meters. So I want you to see that with the same idea or the same knowledge that you have used here to calculate the side of BC, this one, which is the one that we need here, you are going to use the same idea or the same information to find the side AB, which is this one. We could have started with AB. Whether you start with AB, it's fine, guys. It's not like you have to start with BC. No, Yes, because this is the one that I just mentioned from this side of the triangle, but you can even start with this side of what? Of the triangle. So to find AB, this time we are going to concentrate with triangle BD to A, this one. We are going to focus on this right angle triangle because our ratios, they are found on a right angle triangle. So on this right angle triangle, you are going to calculate the side AB. But according to the angle that you're given, according to this angle of 48 degrees, what is this side that you're given, which is what you are given? Remember, I said you use what you're given. What are we given? We're given BD, which is the opposite, okay? What are we supposed to find? We are supposed to find AB. And what is AB? According to the angle 48 and the 90 degrees, they are adjacent to each other. So this is the adjacent. So we are going to take a ratio that is going to apply opposite and adjacent at the same time for this triangle here. And which ratio is that? Again, we are going back to the ratio of tan, opposite and adjacent. So that is the, so here I'm gonna calculate AB, like I said here. So that means we're gonna use the tan of theta again. The tan of theta, the angle this time on this triangle ABD is the angle of 48 degrees, which is equal to the opposite. The opposite is the one that we are given, which is the side of what? Of 35 over the adjacent, which is the one that we are supposed to calculate, which is AB. So this is over AB. So like I said, this is same as over 1. So we can cross multiply so that we determine the value of what? Of AB. So this multiplies this side, this multiplies this side. Okay, so let us multiply, guys. AB times tan 48. It is going to be AB tan of 48 degrees, which is equal to, we multiply this side 1 times 35, which is 35. So like I said, this is a product here. So to find AB, you simply divide by the tan of what? By the tan of 48. Okay, by the tan of 48 both sides, by the tan of 48 both sides. So this will cancel. You remain with AB. So AB is going to be 35 over the tan of what? The tan of 48 degrees. Okay, so like I said, on our calculator, I can do that. And already our calculator is, we fixed, as long this fix is still there, remember, we fixed it to 2 decimal places. So whatever that we are going to do here, it is going to be to 2 decimal places. So it's 35 divided by tan 48. So this is tan 48, okay, 48, which is going to give us 31,51. So this is 31,51 in meters. You use the units that you are given throughout. You're supposed to maintain your units in that case, okay? So that's 31,51 meters in that case. But now, remember, the question here is to find AC. That was the question, to find AC. And you said AC is the sum of the two, AB and BC. So it means now we can be able to determine the length of AC, okay, which is the one that we are given on our question. So therefore, the length of AC in this case is going to be what? The sum of these two. We are going to add AB and BC. From A to B and B to C. You have got what? You have determined the whole of this side of AC up to C. You combine the two sides, AB and what? And BC. Our AB being 31,51 meters plus BC, our BC being 38,87 in what? In meters. So this is going to give us AC also in meters, okay? So here we are just adding. Already we've got these values, this value on our calculator, 31,51. So we are simply going to add 38,87. So this is 38,87. And that is going to give us 70,38. So this is 70,38 in meters. So that is how we could have calculated the whole of the side AC using this information. So what is important is that you are supposed to work with your right angle triangle. Yes, which is actually true. Like I said in our previous class, that we can use a right angle triangle to calculate unknown sides and also to calculate unknown angles. This is what we mentioned here, to calculate sides and what? And angles. So that means you can use that to calculate whatever side that you want, whatever angle that you want, but provided that it is in a right angle triangle and you name your sides according to the angle, okay? Remember I said all the sides in a right angle triangle are named according to the angle that you are working with, okay? You work with the angle, you name the sides according to the angle that you are working with. Okay, so here on this one, on this G, so these are questions which stretch you further just to stretch you. On G, we are given that in the triangle CD, triangle ABC, the whole of this, CD is perpendicular. We're back again to that sign, perpendicular, okay? So it's perpendicular to AB, meaning to say there's a 90 degrees, meaning to also here, there is a 90 degrees here on this one. Okay, then we are given that angle B, this is our angle B here. There's only B here. There's only one B, this one. So there's gonna be a B like this. And AD is 15. From A to D is 15. From D to B 16. So it's like that part that we just talked about to say, if you've got this side and this side, therefore it means the whole of this AB can be calculated. We just add these two sides. This is what we just did to calculate AC. We calculated this one, we calculated this one, we combined it together to find AC. So this time they gave us these sides, okay? Take note here, they gave us these sides, okay? It's different from this one. This time they gave us these sides, so they won't ask us to find AB like this because we just add, okay? But now they want us to calculate the size of theta, which is the size of this angle here. So as you can see, it's just like this one. They gave us, but now they want us to calculate this angle, one of the angles, okay? So meaning to say, you have to ask yourself to say, from this triangle that I'm given here, from this information that I am given, how can I find the angle theta? Which steps can I take? Okay, where is theta? Theta is in this triangle ADC, this one, ADC. That is where we have the angle of theta in this triangle. And so far as we can see in this triangle, there's only one side. And there's nothing that we can do with that side. Remember, in order for you to find an angle under trigonometrical ratios, you must have at least two sides so that it gives you a ratio. Maybe it's the ratio of sine, maybe sine theta is equal to 3/5. You have got two sides. Then you can use arcsine to find the angle. Maybe it's tan of theta, which is 3/4. Then to find theta arctan, you must have two sides. But in that case that we have, we do not have any we do not have two sides. We're just given a side, one side, which is AD. So this is the triangle that, let me just extract it aside like this. This is triangle that I'm talking about here. If you focus, because you want to calculate theta. So for the meantime, you are focusing to say, okay, this is C, this is D, this is A. I'm given a right angle triangle and this side is 15 centimeters and this is my theta here. So if you check, there's nothing that we can do there unless we've got another side. So it's either we are supposed to calculate AC or we are supposed to calculate CD. There must be one of the sides that we can calculate so that we can find theta. But as we can see on this diagram here, it is easier for us to calculate the side CD because it's also part of this triangle that is on this side. As you can see, these two triangles, they share the same CD. So we can take advantage of this triangle here, CBD, this one. It's a right angle triangle, this triangle here, okay? This one. It's a right angle triangle, as you can see, this one. So we can take advantage of this right angle triangle, this one. We use it to calculate the side CD because the same side CD is the one that we are seeing here. CD is common between the two sides, okay? This CD is what? Is a common side. Is a common side. So if it is a common side, let us calculate that CD first, okay? How can we calculate this CD from this triangle that we have got? Because there's an angle and there's a side. We know that we can find another side if it is like that, okay? Using which concept? According to this angle, this side, you name it according, because you want to calculate CD, so you're gonna name this, so opposite, it faces theta, as you can see, they're opposite to each other. What are we given? We are given 16, this one is adjacent. The angle of 40 and the 90 degrees, they are sitting together on this line. So they are adjacent to each other. So there we have got an adjacent. So which of the ratios are you going to consider where there's the opposite and the adjacent at the same time? So as you can see, we are back to that tan of theta from our SOHCAHTOA concept. All right, so like I said, firstly, we are going to calculate what? We are going to calculate CD. So the first thing is to calculate CD before we talk about what? Before we talk about the angle theta. First, we're going to calculate CD. So the ratio that you're going to use with opposite and adjacent is for tan, opposite over adjacent. So the tan of theta, which is the angle, theta is the angle, the tan of 40 degrees is equal to the opposite over adjacent. So it's opposite, this one, which is CD, over the adjacent, which is what? 16. So that is 16, all right? So this is CD over 16. So you're gonna have CD over 16 like this. So how do I calculate CD? This is same as over 1. So you can just cross multiply. This multiplies this side, this multiplies this side. 1 multiplies this side. So it's 1 times CD, which is CD is equal to 16 times tan 40, which is 16 tan of 40 degrees. So that gives you the value of tan from, the value of CD from the ratio. So you choose, there's only one ratio that is going to consist of what you want and what you're given. There's only one ratio that can contain those two. So from that ratio, it cannot be cos and tan at the same time. It's impossible. It cannot be sine and cos at the same time, as long as you're dealing with one, unless maybe you use this angle here. That's where the ratio can change, because according to this angle, this side, it changes. It's now adjacent. This one is now our opposite. So you see, according to that angle, everything changes. So we are using this angle here, this one. So that is what you're going to have at the end. So on our calculator again, like I said, our calculator is already fixed to 2 decimal places. So you're going to have our answer to 2 decimal places. 16 tan of 40 degrees is going to give you 13,3. So this is 13,43 centimeters. Okay, these units are in centimeters. So it means this length of CD is in centimeters. This is not our question. This is not part of our question. Okay, our question was not asking us to calculate CD. No, the question is asking us to determine or to find the angle of theta. That was our question. But as we saw that it was, we had a limited triangle, this one, it was a limited triangle. But now that we have the length of this CD, which is 13,43, because this is now 13,43 centimeters this side. So we can use that to calculate what? The angle now, because like I said before, we can work with our trigonometrical ratios to find an angle. At least you must have two sides. You must have two sides. So once you've got two sides like this, how do you use your ratio? According to theta, this is your opposite, this angle here. This side here, it's your opposite to theta. They are opposite to each other. And 15 is the adjacent. So we are still back to that tan. The tan of theta. Now we are finding theta now. So we have to find theta this time. So the tan of theta, which is the angle that we want to find, this one, we are not going to substitute anything because we do not have that angle. So we're just going to write tan theta is equal to opposite over adjacent. So what is the opposite according to theta? According to theta, the opposite is CD, the calculated side, which is 13,43 over the adjacent. According to here, we need the adjacent, and our adjacent is what? Is 15, which is the side that you're already given. So you can write it as a decimal, which if you want, but you can just find theta. Remember, I told you guys to, from our trigonometrical ratios, to find the angle theta, this one, theta represents the angle. You write tan on the other side. You take this tan on the other side. But how do you write this tan on the other side? You take it as arctan. So it is going to be written as arctan on the other side. So that is the simplification that you just need, okay? If you're working with anything that is under an angle, that consists of an angle, to find the angle there, you take that ratio to the other side of the equation, but it carries a negative like this, which is arctan. So this is arctan, arc cos, arc sine, like that, okay? So since this is tan, it's going to be arctan. 13,43 over what? Over 15. Okay, remember, this was 15. So this now gives us the theta. The question that asked us to calculate theta, not CD. CD was just part of the, we had to, because we needed this in our simplification. There's a part that needs us to determine the side in order to have the theta. So that was the reason why we had to find the angle, the side CD. Otherwise, we're not even worried about that. If the triangle was completely having all the information, there was no need. Okay, so on your calculator, find tan, arctan. So this is arctan, shift tan. It writes a negative exponents there. So it's shift tan 13, comma, so that is 13,43 over 15. So this is over 15 like this. So you're going to close your bracket. This gives us 41,84. So that's 41,84 degrees, okay? 41,84 degrees. So that is going to be the value of your theta to 2 decimal places, depending with the instruction that you are given for that particular question. So as you can see, that is how we could have calculated the angle theta. So it's not like you're going to have a triangle which is direct, where the information is direct. You sometimes they give you information like this, where you have to figure out. You have to figure out, how can I determine the angle theta from this triangle? Can I find anything that can help me to find theta? Yes, I can determine the opposite, which is CD, which is the common side. Having this common side, I can use it now to calculate theta, because now I can name my triangle according to theta. This is opposite, and this side is the adjacent. And there's only one ratio that is called opposite and adjacent, which is the ratio of what? Of tan. Substitute into your formula, then we can use your calculator to determine the angle that you are given to, that you're asked to find actually. Okay, so that is how the questions might be given as. So as you can see, it is the same scenario that we have on question H. Using the information provided on the given diagram, calculate the length BC. All right, take note where BC, take note where BC is here. At the end, after this triangle, guys, there's a lot. Okay, so anyways, this is what you're going to consider. Let us see our triangle. We want to calculate BC, remember. All right, so here we want to calculate BC. All right. We are supposed to calculate. Okay, just hope there's something that I must open, or is it a software or what? Calculate BC. So this is our question. But before we think of that BC, because if you are to consider this is a right angle triangle, okay? Here I've got a right angle triangle here. This one, a right angle triangle. What about this one? Is it a right angle triangle? Yes, it's going to be a right angle triangle. Why? Because if you see here, you consider here, it's a straight line. And we know that angles on a straight line, they add up to 180 degrees. So these two, they must give us 180. There are angles here. We can see two angles there. So these two angles must give us 180. So it means it's going to be 90 minus 180 minus 90, which is 90. So this one is a right angle triangle in actual sense. All right. Anyways, this is something else. Okay. Let us consider this. That it's a right angle triangle is fine, but how can we find BC? I want you to see, if we take this right angle triangle, if you take it like this. All right, let's just put it this way. This is our right angle triangle from A to D, from A to D to E. Okay, we said it's right angled here. There's a 90 degrees there. Okay, and we are given 70 millimeters here. This is 14 degrees. So if we are to consider that triangle, we can be able to calculate this side AD. We cannot think about ED, because look at where ED is, guys. And this cannot even help us to find this side. It cannot even help us to find this side. But if we calculate here, if we calculate this side AB, at least we have an assurance that it can help us to calculate AC. Then AC can help us to calculate what? To calculate BC. So it's that pattern. So CD, AD, we can calculate it because we're given a right angle triangle, and this, according to 14 degrees, this angle, this is adjacent. These two sides, these two angles, they are adjacent to each other. So this is adjacent. And this one faces the 90 degrees, the longest one, the longest side, which is what? your hypotenuse in that case. So you've got the hypotenuse. So according to the angle of theta here, we can use which ratio? That is called hypotenuse and adjacent at the same time from our mnemonics. So Katoa, we're gonna just check here. Adjacent and hypotenuse is on cos. So meaning to say the ratio for cos was gonna help us to calculate AD. So we are going to calculate AD first, okay? So according to the ratio of cos, it states that the cosine of theta, which is the angle here, the angle that we have, that is our theta, right? So the cosine of theta is equal to adjacent over hypotenuse, adjacent going to the hypotenuse, and our adjacent is AD, the side that you are supposed to calculate over the hypotenuse, which is 70. So we can find AD if we cross multiply, that's gonna be AD in this case is going to multiply this 1 times AD, and this 70 multiplies this side. So that's 1 times AD, which is AD is equal to 70 times cos 14. So this is 70 cos of 14 degrees. All right, so that was going to give you the size of AD, all right, in millimeters. As you can see, the other units are in millimeters, the ones that you're given. So there we just need a calculator to simplify, and our calculator, it's already fixed it to 2 decimal places. Whatever that I simplify now, it is to 2 decimal places. So this is 70 cos 14, which is going to be 67. We saw 67,92. So this is 67,92 millimeters like this, okay? So like I said, having this length 67,92, it can help us because this side here is 67,92, this one, 67,92 millimeters. So we can take that now to calculate AC, because we can see that we are also having a right angle triangle here. So we can calculate, because we've got a right angle triangle, so you can calculate AC, and AC helps us to calculate BC. Remember, guys, we need BC. So we have to walk step by step, okay? So according to triangle ADC, according to this triangle here, let us name our sides, what we are given and what we want to calculate. What are we given? According to the angle of 36 degrees, the side, this one that we just calculated, which is our AD, now is the adjacent. So we've got adjacent. What do we want to calculate? We want to calculate AC, this one. Remember, we want to calculate AC. And AC is what, according to 90 degrees, is the hypotenuse. It faces 90 degrees, so it's the longest side opposite the biggest angle. So that's, we're going to use the ratio for cos, adjacent and hypotenuse at the same time. So remember what we had about here, cos. So this time, we're going to calculate AC. Okay, from where? From triangle ADC. So you're going to use triangle ADC. Okay, so from triangle ADC, we saw that what we are given and what we want to find is opposite, it's adjacent and hypotenuse, which is from the ratio of cos. So it's going to be the cos of theta, which is the angle that we have here, which is 36. So the cos of the angle 36 is equal to the adjacent over the hypotenuse, the adjacent, which is 67,92 over the hypotenuse, which is the side that we are supposed to calculate of what? Of AC. So we can calculate AC, cross multiply, this AC multiplies this side, this one multiplies this side. So whatever way that you want, but I always multiply in a way that I see the unknown on the right hand side. Like this one, if I want it, I can just take it this way so that I just remain with AD here. It's no matter the way. So if you want, you can just multiply it direct like this, AC times cos. So it's gonna be AC cos of what? 36 degrees, which is equal to 67,92. How do I find AC? I divide by the cos of 36 by the cos of 36, both sides. So this will cancel and I remain with AC, okay? So let's see, okay, let's see. On our calculator, you're gonna divide 67,92, 67,92 like this, everything over cos of 36. So this is cos of 36 degrees, okay, which is 83,95. So you're going to obtain 83,95 in millimeters, okay? These dimensions are in millimeters, okay? Now we can conclude to find the side that you want to calculate, which is BC. So this is our AC, the one that we just calculated now. So according to this, we got our AC as what? 83. So this was 83.95 millimeters. So we can use this side of AC to find BC because we are now having a right angle triangle, an angle, and a side. Once you have an angle and a side, guys, on a right angle triangle, you can be able to calculate the unknown side that you want to calculate, okay? So in order for us to calculate BC, which is the one that we want, we are going to name our sides according to the angle that we are given. So which angle are we given? We are given the angle of 20 degrees inside. So according to the angle of 20 degrees here, this BC that we want to calculate is the opposite. They face each other. And what are we given? We are given the one that faces 90 degrees is our longest side. So that is the hypotenuse. So there's only one ratio there that has got opposite and hypotenuse at the same time. Which ratio that has got opposite and hypotenuse at the same time? That is the ratio of sine. So now we calculate our BC. So now we're going to calculate BC finally, okay? So we saw that the best ratio is the ratio for sine. The sine of theta is equal to what? The sine of theta is equal to the opposite over the hypotenuse. So we are just going to fill in our information. So we said according to the theta, which is 20 degrees, our opposite is BC, the side that we want to calculate. So it's cos of the angle, sine of the angle, sorry. So it's going to be sine of the angle. We said 20 degrees is equal to, so the angle there, theta, 20, opposite, which is BC, over the hypotenuse, the side that we just calculated. So this is opposite, which is BC, over the side that we just calculated, which is AC, which is 83.95. So we can calculate BC because this is same as over 1. So all you just need is to cross multiply here, cross multiply here. So that gives us BC. 1 times BC, that is BC is equal to 83.95 times the sine. This is going to be 83.95, the sine of what? 20 degrees. Okay, so from there, you have the side BC. So this is how you play around with this information, okay? So you can just use all your ratios. In sometimes you can just use one ratio. So it determines it's determined by the question that you're answering. It's not like you're gonna know that I'm gonna use tan or I'm going to use cos. No, that one you can't tell. So this will give us 28.71. So that's 28.71 millimeters. Like I said, the units, we maintain the units that we have been given before. So this is in millimeters. Our answer also is going to be in millimeters, as you can see. So this is how you're supposed to answer this question. Just have to figure out which triangle is best to work with for a certain time. What can I get from that triangle that can help me to find another side or something from another triangle? Don't waste time calculating something that cannot be used in another triangle to find anything. You work a side that you are not going to even use. So it's not gonna work, okay? It's not gonna work. You work with what helps you to find another side from another triangle. Is maybe an angle, depending with what you're supposed to calculate in that case. All right, so this is how you're supposed to answer this question. Then on item I, there we are given in the given diagram, okay, in the given diagram here, we've got a given diagram. Triangle ABC is a right angle triangle. So this one is a right angle triangle. As you can see, it is given that AC is 4 units. From A to C, it's 4. And tan A is given as 3/2, and angle A is in between, that is an element from 0 to 90. Angle A, that is an acute angle. This angle A, they are simply saying angle A is an acute. And definitely, guys, it's inside a right angle triangle, so there's no way A can be more than 90. It's going to be an acute angle, so this thing does not even work. All right, so anyways, we are given that AC is 4 units. Then we are given the tan of A, which is what? 3/2. So they are saying the tan of this angle is 3/2. How do you find the ratio of tan? So let us just write this ratio aside here. They are saying the tan of angle A is equal to 3/2. Remember from our soccer tour. So this one, they gave us the ratio already. So what you just need to know is that you can play around with your ratio. All right, remember that our ratio from our soccer tour concept. This is soccer tour like this. Okay, we are supposed to have the tan as opposite over adjacent. The tan of A, which is theta, the angle here is supposed to be opposite over there, which is the opposite here. According to A, this is opposite, and this is the adjacent. So we know that is supposed to be opposite over the adjacent. All right, this is the tan of the angle A, which is the opposite here, it's BC over AC. Okay, so that is according to the formula, but that does not even matter. So if we're to substitute, we're going to see that here we're supposed to have opposite, which is BC. So this represents BC, this represents AC. But if we check AC here, it's 4. Here it's 2. So there's something that here, it means this ratio was being reduced, okay? This ratio was being reduced because, okay, in actual sense, they are saying, determine the length of BC without solving for angle A. Okay, this is what you do. Because this one is being reduced. As you can see, according to this, the tan of A is supposed to be a certain number, okay? But here is supposed to be 3/2. But as you can see, according to our side AC here, this side AC is 4. So what happened in order for us, it means we had a certain value, we had a certain value like this over a certain value like this. Then we reduced that number, we got 3/2. But what we know that the original value, like what we have here for AC, this one, it's a 4. So which number did you use to reduce this 4 to give you a 2? That is how you simply ask yourself, which number? It's a 2. If we divide this by 2, we get a 2. So how do we get back now to this side here, from here? How do we get back? If we divided this by 2, because remember, like, it's like you're simplifying. I want you guys to get this. Don't be confused, okay? It's like you're simplifying your questions, okay? You get an answer after you get an answer like 5/10. Yes, you can leave your answer like that, but is it how you're supposed to leave it? No. On a calculator, it simplifies, it gives you 1/2. So this is what is going to happen. It gives you 1/2. Sorry for that. Let me just change back. It gives you 1/2. You reduced this by 5. 5 into 5, you get a 1. 5 into 10, you get a 2. So this is what is given here. They gave us something like this, which is reduced already. As we want to get back, what was the number before that we had? So at least we have a clue like this one. They give you, if you know that here it's a 5. So you know that you simply multiply this by what? By 5. 5 times 1 is a 5. So you're going to multiply this by 5. It gives you a 10. So this is what I'm just asking you guys, okay? If you get this, it's fine. But if you didn't get it, I think now you understand what I was trying to say. Okay, so meaning to say, from here to this side, where we have got 4, we are going to multiply by 2. We just multiply by 2, we just multiply by 2. 2 times 2, that's a 4. So 3 times 2, it's a what? It's a 6. So it means BC represents what? 6, because we say our ratio B is supposed to be BC over AC. And according to this, our BC is the one on top. So BC will be equal to what? Be equal to 6. So that if we get 6/4 like this, we reduce by 2, we get a 3. By 2, we get a 2. So this is the 3/2 that we see here. It was a reduced value. So that's why they are saying we can calculate this BC without using it, without even solving, without even finding angle A. That's what they are saying here. Without solving for angle A. They are saying don't solve for angle A, okay? Then after that, calculate the size of B, okay? Calculate the size of angle B. So there are 2 ways to calculate the size of angle B. This is our angle B. They mentioned angle B direct because there's only one angle B. So there are 2 ways. You can find angle A if you want, or you can just leave it like that because there's no need for you to know about angle A. Because we now know that this is 4, this is 6. So you now ask yourself, so this is question 2, okay? So this is item 2. We want to calculate angle B, okay? So like I said, this is item 2. Now we want to calculate the size of angle B. So what you just ask yourself, because already you've got sides which are fine. angle of the side of 4 and the side of 6, they are enough for you to find a ratio and use that ratio to determine a side. That's what I said. 2 sides are enough. So according to angle B, let us name our sides. According to angle B, this is the opposite. They are facing each other. So we have got the opposite here, and this is our adjacent. These 2 sides, they are adjacent to each other. So like I said, there will be only one ratio that consists of the opposite and the adjacent at the same time from your trigonometrical ratios. And which ratio is that? Opposite and adjacent, that is the tan. So we've got opposite here over the adjacent. So according to the tan, we are saying the ratio of tan states that the tan of theta must be equal to the opposite over the adjacent. And in this case, we are talking about the tan of theta, which is the angle to be calculated, which is angle B. So that is angle. Remember, theta is the angle. So the tan of angle B is equal to opposite. According to this, what is our opposite? According to B, not according to A, because we want to calculate angle B. According to angle B, our opposite is what? Our opposite is 4, and the adjacent there is a 6. So that is, now we can calculate our angle B. So that means our angle B is going to be, remember how you remove tan to be written on the other side, it is going to be written as arctan. Okay, so this is arctan 4/6. So this is how you find your angle B. Okay, so that's arctan of 4/6. We're going to have our angle. So let us see on our calculator, what are we going to have? So this is arctan shift tan 4/6. That is arctan, it's just shift tan. So you're going to have 33,69. So this is 33,69 degrees. Okay, so that was going to be your angle B. Okay, so with this angle, you can even determine angle A if you want, but that was not about angle A, it was about angle B. Okay, so these were the steps. You just needed the ratio that you're going to use because you already have the 2 sides. Okay, then after that, they want you to calculate or to determine the length of AB, which is this one. So there's no need for even me to use these trigonometrical ratios of this and that because it's a right angle triangle. So I can even go back to the Pythagoras theorem. Okay, remember our Pythagoras theorem. We want to calculate AB in that case, and we know that Pythagoras theorem states that hypotenuse squared is equal to side squared plus side squared, where this is the hypotenuse, the longer side, which is AB. So you want to calculate AB, so that's AB squared is equal to the shorter sides squared. Okay, so you're going to have 4 squared plus 6 squared. So that's AB squared is going to be 4 squared. Remember, 4 times 4, guys, is 16. 6 squared, that's 6 times 6, which is 36. Then you're going to add these two. All right. Okay. Sorry for that. I'm now rushing here because of this time is too much. I want us to finish this class. Okay. So this will be AB squared is going to be, you add these two. What are we going to have there? Let's say 60 what? 60, 70 something or 80 or what? Okay, let us just add. Why am I having, all right, it's 4 and 6 there. Okay, that's 4 and 6. So it's going to be, okay, let us just add. I have the calculator already here, but you can just add direct 16 plus 36 like this, which is going to be, okay, it's because I rounded or I fixed this. So just go back to the normal, okay? You press 8, okay? Then it gives you normal, so it's 52. So it's just going to be 52. Then to find AB, you're going to introduce the square root both sides. So this will be AB. So AB is the square root of 52. Or you can simplify because this we've got a calculator, then square root of 52 or the square root of the answer, which is going to be 7,21 and so on. Or you can just fix to 2 decimal place, press 2, there's going to be 7,21. All right, so that's 7,21. That is our AB in units. Okay, if the units are not given, you just write units. So this is our AB, which is just measured in what? In units, like that. So I hope we are together. Or you could have used the angle, then we use our trigonometrical ratios to find that side. It's still fine. You can even use the trigonometrical ratios on a condition like that. But I Just want us guys to refresh our mind with Pythagoras, okay? I think now you now know that even Pythagoras can be used where trigonometrical ratios are being used, okay? Then the last part, which is our question J here, is and the triangle PQR. I've got a triangle and you're given this information that QS is perpendicular to QS and PR. So meaning say it's 90 degrees. So this is also perpendicular 90 degrees. I talked about this. And this is H units, QS, which is 8 H units, PQM units, PQ is M, QR is N units. Okay, so this one, where is it coming from now? It's just a mistake there. Okay, no problem. First question, express the sign of P in terms of H and M. The sign of P in terms of H and M. This is this one, the sign of, already they told us guys the ratio to use the sign. So there is just direct SOHCAHTOA. Okay, so that one is very, very direct. Okay, SOHCAHTOA. So the sign is opposite over the hypotenuse. So the sign of theta is supposed to be opposite over the hypotenuse. Okay, but this one you're talking about the sign of angle P. So it's going to be sign of angle P. So the sign of angle P, according to angle P here, this is our opposite, and this is our hypotenuse M, okay? And we are just given direct there. So opposite, which is H, over the hypotenuse, which is M. So this is the ratio for sine P, direct like that, okay? Number 2, express sine R in terms of H and N. So this is the sine of angle R, okay? So the sine of angle R here, according to this, is opposite again. According to angle R, this is opposite, and this is the hypotenuse. So it's going to be opposite, which is H, over the hypotenuse, which is N. All right. Hence show that these two, they are equal. Sine M sine this is equal to this. Okay, hence show that. Okay, this is no longer about the triangle, guys. This is no longer about this. No. Don't confuse. Hence, it's a continuation from these two. Okay? Okay, let us write our hence, because this one we have to prove. It is us we're supposed to prove. You're sure that is to prove, okay? So we are supposed to show that M sine of P is equal to N sine of, okay, let us show. This is what you're going to do here. If we check from our previous results, these previous results, this one, there's something that is no longer given here that we no longer see on our answer. That was there before on these ratios that we determined. There's something that we saw, but now it's not there. What is it? It's H. We have M, we have M, we have P, we have P, we have N, we have N, we have R, we have R. Where is H? Where is H here? Where is H? H is not there. So it means what they simply did, what they want you to do, they simply made H the subject. They got H, and since H is common and equal, so it follows that H must be equal to H. There's no way that H cannot be equal to H, guys, okay? So here, from this one, you're gonna find your H, this side. The sine of P is equal to H over M over 1. So let us find H, cross multiply. 1 times H is equal to M times the sine of P, which is M sine of P. Okay, so this is the value for H here. This is the term representing H from this one. We just cross multiply whatever that we did there. Okay, which is the same thing that you're gonna do on this side. Find H again, because we're given that the sine of R is equal to H over N. This is same as over 1. So you're gonna cross multiply just like the previous case. 1 times H, which is H, is equal to, this is N times sine R. So this is N sine R, like this. Okay, so we've got H here, and this H that we see here, and this H, they're equal. It can't be that there's an H there, there's another H, then those H, they're not equal. It's impossible. So if this h is equal to another h, therefore it means this m sine of p must be equal to n sine of r, which is proven, or you can just say shown, because they said you must show this. Okay, so that is how you could have shown that these two are the same. M sine p is equal to n sine r, just like that. It's a continuation, hence means from what you have just did, from there, continue from there. Okay, another continuation again is like this. Now use the result in 3. It's like from here. What you just proved, you have to go back again. It's a hence again. So they are saying hence calculate the size of angle P. If it is given that M is 40, N is 30, and R is 80. So it's just a substitution. This is question number 4. So this is just a substitution that you're going to make, because already we have made whatever that you want here, the equation. So you're just going to substitute whatever that you're given. Then you can calculate angle P, because you're given M. So remember, M sine P is equal to this. So M there is given as what? We are given that M is equal to 40. All right, so it's going to be M, which is 40 here. So remember I said M is 40, so it's going to be 40. Sine of P is equal to N. What about N and R? All right, N here is what? N is 30, R is 80. Okay, so N, we said, is 30, sine of R, which is 80. Okay, let's just confirm. N is 30, R is 8. Okay, so you want to calculate P. So definitely you can find the size of P, because as you can see, this is just an equation. So it's like you're solving for an equation here on this one. Take like you're solving for X, or you're solving for what. So this time you want to find P, but P is carried on this part that has got sine. Remember, when you say sine P, it represents the sine of the angle P. So this 40 is not an angle, you can remove it. How can you remove this 40? You can simply divide by 40 here. We can divide by 40 this side. So this will cancel. You remain with the sine of P, which is equal to the whole of this part. You can write it as a decimal, it's up to you, okay? You can write it as a decimal, it's up to you. So I'm just gonna go back to the calculator and use it in the normal mode. Remember, I showed you how to go back to the normal mode. So this is going to be 30 sine 80, okay? So I'm just gonna have as a fraction this side as it is 30 sine of 80 degrees, like this, everything over 40. So if you check, you're going to get a decimal there, 0.7386 and so on, 0.7386 and so on and so on and so on. It's an endless decimal that you're going to have. So how do I find P now? So P is the angle, just like the previous part, whether it's from a straight ratio or whatever that you're dealing with, whether it's a fraction or this and that. To find the angle P, you remove arc sine and write it the other side as arc sine. So meaning to say angle P was going to be arc sine of this decimal. So it's going to be shift sine. We've got arc sine of that answer that we got, which is the decimal, this one that we got. We are now having angle P 47.61 and so on, which is 612. So it's going to be 47.61 to 2 decimal place 1, 2. This one cannot change, or you can use a calculator, shift, set up, go to the fix here on 6, 2 decimal place is going to be 47.61. So this is 47.61 degrees. Okay, so this will be the angle P that you were asked to be, that you asked to calculate in that scenario or in that case. So as you can see, the application of 2D is just a normal thing that you are used to, as long you understand your trigonometrical ratios. It's just that some questions you need to think along the lines, think inside of the box that you are working with. There's a solution inside of that box. Yes, you're told to think outside of the box, but I say think inside of the box, because inside, that is where the solution is. Okay, on your triangle there, the solution is there, not out of this information, inside this information. So work with the information that we have told you guys from the trigonometrical ratios our mnemonics, SOHCAHTOA, that we use them to write the ratios. And like I said, that these trigonometrical ratios, they are best to be used in calculation of sides and angles. And we have noted that throughout that we saw calculating sides, we saw questions like these ones where we are even calculating angles, whereby an angle is to be simply arcsine or arccos or arctan of whatever that you are given on that trigonometrical ratios. So it needs you now to revise your question papers, check how do they ask questions. So we've got so many question papers to work through, revise those question papers so that you'll be able to understand and also prepare yourselves for the exams that are ahead of time. You'll be geared up for those exams, okay?